Hi, in this video, I want to talk about powers of 10 and how to apply powers of 10 into writing numbers in a form that we call scientific notation. In the UK, they actually call it standard notation. I'll show you why we bother using scientific notation, what's so good about it, and how to convert from the usual way of writing numbers into scientific notation and backward from scientific notation back to regular numbers. I'll also show you how to multiply and divide numbers written in scientific notation format. And at the end, I will briefly touch on the topic of engineering. And at the end, I'll briefly touch on the topic of engineering notation. All right, let's talk about powers of 10. First of all, let's talk about positive powers of 10. What's 10 to a third? 10 to a third is number 10 multiplied by itself 3 times. I could ask you to hit pause and use your calculator to multiply it out. But I know a good way of multiplying numbers by 10. When you multiply a number by 10, all you need to do is put an extra 0 at the end of it. For example, if you have the number 88 times 10, then just put an extra 0 at the end of 88. The answer is 880. If you have a decimal number, 1.62 multiplied by 10, then you just move the decimal one place, 16.2. So knowing that kind of shortcut, this 10 times 10 becomes the first 10 plus an extra 0. Then times 10 again, I get 100 with an extra 0, I get 1,000. The final answer, 1,000. Well, let's look at what we did. We had 1 0 out of the first 10, and we add on another 0 out of the second 10, so we have 2 zeros, and we add on another 0 out of the third 10, and we have 3 zeros. So it looks like every time you raise 10 to the power anything, I'm going to do 7. I have a 10 times another 10. The first 10, the original 10 gives me 1 0, and the second 10 gives me 2 zeros. The third 10, the fourth 10, the fifth 10, the sixth 10, and the seventh 10. I have 7 10s. It gives me 7 zeros. 1, 2, 3, 4, 5, 6, 7. And by tradition, we go in and put a comma for every group of 3. All I do is I take each 10 and I contribute a 0 to the number. Well, how many 10s? 7 10s because of the power 7. 10 to 7th automatically gets you the number 1 followed by 7 zeros. So for positive power of 10, you have this rule. 10 to the something is equal to 1 followed by a bunch of zeros. And the number of zeros is the same as the power of 10. Well, that gets us a pretty good shortcut because of this. If I write out this number, if I hand this number to someone, they're going to have to sit there and count how many zeros I've written down. Well, I know that this is the same as 10 to the 15th, right? Because of this rule. So if I just tell people that I just gave you the number 10 to the power 15, they don't need to sit around and count the zeros. They know it's the number 1 followed by 15 zeros. This makes this a shortcut. It's easier to tell people that there are 15 zeros than to write down the 15 zeros, hoping that I write down correctly and hoping that they count correctly. That's the motivation behind scientific notation. Instead of telling people this number, I just tell them this number. First, it's shorter, and second of all, no need to count the zeros. But what about this number then? How can I abbreviate this number using this kind of format? So first of all, I don't want you to think that it is 50 to the 6th, okay? 5 million is not 50 to the 6th. If you hit pause and get your calculator and calculate this number is 15 billion 625 million. It is not 5 million. Well, then how do we abbreviate this then? Well, the way we abbreviate this is you think of 5 million is 5 times 1 million. And I know what 1 million is. 1 million is 10 to the 6th. And therefore, 5 million is 5 times 10 to the 6th. This way of writing a number is called the scientific notation. The reason why we use this is because it tells people very quickly that we're looking at a number in the range of 10 to the power 6, in the range of 1 followed by 6 zeros. Let's do another example. Let's say 71,400,000. How do I convert this into scientific notation? 71,400,000 is in the range of 70 million. It's in a range of the 10 millions. Yeah. So it's in the range of the 10 millions. And how many 10 millions? 7 something. Well, I want it to be kind of like 7. So I go 7.14. It's basically 7 times 10 million. In scientific notation, is 7.14 times 10 to the 7th. So let's define scientific notation. Scientific notation is a number like this. It is some number C, perhaps with a decimal, times 10 to the power something. So I call it K. And at this point, I'll add an extra wrinkle to this. You can have scientific notation for a positive number, or you can have a scientific notation for negative numbers. So it could be positive or negative. This number in front here, it is called a coefficient or the digits. Different people call it different things. And the rule is the coefficient or the digits must be at least 1 and less than 10. What does that mean? What kind of number is at least 1? Well, 1 is at least 1, right? 2 is at least 1. And also numbers between 1 and 2, 1.3, 1.08, etc. So at least 1 means it has to be at least 1 point something, or 2 point something, or 3 point something, 4 point something, etc. And then you get to 9 point something, still okay. And then 10 point something, yeah, 10 point something is at least 1, but we also want it to be less than 10, so we don't take 10 point something. We stop here. What this rule says is that we want this coefficient or the digits here to be 1 point something, 2 point something, etc., up to 9 point something only. We don't want it to go too low. We don't want it to be 0 point anything. And we don't want it to go too high either. We don't want it to go to 10 point something. And why not? Because the whole point of doing scientific notation is that we can look at that number 7 and we say that it is equivalent to the range of 1 followed by 7 zeros. 1 followed by 7 zeros is 10 million. We want to correctly identify that this number is in the 10 million range. If you have this number that's too small, then it's not yet 10 million. You have this number of 10 or more, then you'll reach into the range of 100 million or more, and that's the wrong range. Right? So the purpose of this rule is to make sure you stay within range of this, which we call the order of magnitude. This number has an order of magnitude in the 10 millions, and the coefficient or digits have to stay this way to be within that order of magnitude. So on the one hand, it's a rule, it's a definition, but on the other hand, there was a reason for it. All right, now let's talk about how to convert a number into scientific notation. Let's take an example of what that we've already seen. 71,400,000 is equal to 7.14 times 10 to the 7th. We noticed that we started with 714, no decimal, and we end up with 7.14. Where did this come from? The original number didn't have a decimal point, yeah? Oh, no. The original number did have a decimal point. It's a whole number, it's an integer, and all whole numbers have an unwritten, invisible decimal point right there. It got moved from there to there. How many places did it move? It moved by 1, 2, 3, 4, 5, 6, 7 places. I didn't count the commas because commas on a place in the number, right? Only the numbers are places. It moved 7 places, and that's the same as that 7 there. Let's look at the 5 million. At the number 5 million we had before, and we figure that that's 5 times 10 to the 6th. This number has an invisible decimal right here. And how many places did it take for the original decimal to get to that spot? 1, 2, 3, 4, 5, 6. And that is a 6. Right, these two examples give me confidence in what the steps are. I'm going to write it down. First, I'm going to find the decimal point. Like I find it here. And I move it to the left until I get to the point where the digits are 1 point something, 2 point something, up to 9 point something. I don't stop too early. For example, with the 71 million, I don't stop too early here at 71. I go all the way to 7. And I don't go too far either. If I go one more step over, I'll end up with 0.714. And I don't want that. I want to stop at the right spot. That means I move it to the left until I get the form between 1 point something and 9 point something. I count 1, 2, 3, 4, 5, 6, how many places I have moved. That is the power of 10. So in the example of 5 million, I counted that I'm moving 6 places, then the power of 10 is 10 to the 6th. Let's do a very long number. So go ahead and hit pause and try this, and then come back. All right, number 1, find the decimal, and for all whole numbers, it's an invisible decimal right there. And I move it until I get to the form I need. A single digit followed by a decimal, meaning I want to arrive there. This is too early. This is too late. Okay. To get there, I go 1, 2, 3, 6, 9, 12, 13, 14. I moved by 14 places. So the answer is times 10 to the 14. And then the decimal that I have, digits, the coefficient is 3.146. And that is my answer. That's how you work with positive powers of 10 in scientific notation. Positive power of 10, because it's 1 followed by a bunch of zeros, it relates to large numbers. Now let's talk about what happens with negative powers of 10. Negative powers means 1 over the positive power. So 10 to the negative first or negative 1 power is 1 over 10 to the first, which is 1 over 10. And then if I divide this out, 1 divided by 10, so go ahead and try that on your calculator, is 0.1. 10 to the negative 2 is 1 over 10 squared. It's 1 over 100. And again, get out your calculator and divide it. What you get? You should get this, right? 0.01. 10 to negative 3, if you go through the same process, you end up with 0.001. Let's do one more, 10 to negative 4. Go through the same process, 1 divided by the number 10 to the 4th, which is 1 followed by 4 zeros. You see the pattern in terms of how many decimals there are. 1 decimal here, 2 decimals here, 3 decimals here, and 4 decimals here. And it makes sense because every time you go to the next negative power of 10, you actually divide by 10. How does division by 10 work? If you have a number like 123.45 and you divide it by 10, then what you do is you move decimal over here, make it smaller, right? You get 12.345. You get 1 more decimal because the decimal point moves. And that's what happens here. 10 to negative 1 gets you 1 decimal. 10 to negative 2, you move the decimal point, so 2 decimal places. Move decimal point again, 3 decimal places, 4 decimal places. So 10 to negative k is 0.00 something 1. K decimal places, counting the 1. So the zeros and the 1. That's how negative powers of 10 work. And now let's talk about using it for scientific notation. How about 0.008? We do it like we did before. We write this as 8 times 0.001. And 001 has 3 decimal places. So that's 10 to negative 3. And the answer is 8 times 10 to negative 3. Do one more example. If I have this decimal, there are 2 things I can do. I can do it as 29 times this kind of decimal, or I can do it as 2.9 times this kind of decimal. Well, we choose to do this for the same reason as before, because it's very close to this number, right? And that number is in the range of 3 decimal places, not 4. Same reason as with the large number, we choose to make sure that this part right here, the digits or the coefficient, is in the range of 1 point something to 9 point something only. We don't go over to like 29. We don't go over that. And that makes this 2.9 times 10 to the what? Negative 3, because it has 3 decimal places. Let's go back to the first example. The original decimal place was here, and I moved it, and then eventually it ended there. So it ended there. How many places did I move? 1, 2, 3. And that matches this negative 3. The original position is here, and I end up here. 1, 2, 3. Matches that negative 3. I will now write down what a negative power 10 is for. Negative powers of 10 relate to a very tiny decimal. 0 point something something. There may be some extra zeros in here as well. Let's now write the rules for conversion from regular numbers to scientific notation. Both the situations where the number is really big and the situation where the number is really small. First of all, you're going to find the decimal point, and you're going to start moving it. If the number is huge, for example, 3 million, the invisible decimal point is here, and you need to move it over there. That means you need to move it to the left. Whereas if it's a small decimal, the decimal point is here, and you need to move it until it gets there. That means moving to the right. Count how many places. If the original was large, then the number of places is the positive power of 10. If small decimal, then the number of places is the negative power of 10. Let's do one more example. 0.0438. I find the decimal point is right there, and I'm going to move it. I move it until I get to a single non-zero digit, then I'll stop. 4 point, I'm done. I don't go all the way to 43 point, yeah? And the way I remember which way to move is, actually, I'm not going to memorize left versus right. I know if I move that way, I'll never have anything point anything. There's a bunch of zeros over there. So I simply have to move to the right. That's where the digits are. And that gets me 4.38. And because I moved 2 places, it's 10 to the, it would have been a 2, except that we're talking about a small decimal, so -2. Like I said, the reality is I'm not going to remember left versus right. I do remember, though, that negative goes with tiny small things, and positive powers of 10 go with really huge numbers. So that's how I'm going to remember it. It also helps me double check my work. If I have a tiny decimal and the answer is a positive power of 10, like this, I know it has to be wrong because positive power of 10 goes with huge numbers, and 0.0 something something is not a huge number. All right, so that's how you convert from a regular form to scientific notation. Now let's work the other way around. Converting from scientific notation. For example, if I'm given that the speed of light is approximately 3 times 10 to the 8th meters per second, how do I convert this back to regular numbers? I just go backward from where I was before. So 3 times 10 to the 8th. It has a hidden invisible decimal point here. And because this is positive, I know it's going to be a large number. So I move the decimal point the opposite way of where I did before. Now we're going to move it backward. We're going to move to the right. But I'm actually not going to memorize it that way. I'm going to memorize it as I'm going to move it in such a way that it lets me arrive at a large number. That means I have to move it this way. And I do that in 8 places. 1, 2, 3, 4, 5, 6, 7, 8. And I fill in with zeros. So this is my answer. 300 million. Let's imagine what happens if I move it the wrong way. 1, 2, 3, 4, 5, 6, 7, 8. I write here and I fill in with zeros. And look, I have a tiny decimal. And that's just wrong because the positive power of 10 tells me that it has to be a large number, cannot be a small decimal. So I just know that this is wrong. I cross it out and I do it again the opposite direction and I end up with the correct answer. Let's now write down the steps. I find the decimal point in the coefficient. If it's positive, that tells me that I'm supposed to result in a very large number. Then I move the decimal point in that direction. And that direction is actually to the right. If the power were negative, it tells me the number is a small decimal. Then I move the decimal point in the direction that makes a small decimal. Which is to the left. If there are blanks, I fill in with zeros. Those are the steps. Let's now do some examples. The width of this COVID virus is approximately 9 times 10 to negative 8 meters. How do I convert this? So first I find the decimal and it is right here. And I'm going to move it. Which way do I move? If I try moving this way and I end up filling in with zeros, I'll end up with like 9 followed by a bunch of zeros, and that's not it. Because the power of 10 here is negative, it's a small decimal. So I know I want to move it that way. By how many places? 8 places. So here we go. 1. Fill in with zeros. And voila, meters. Now, let's talk about how do I correct a wrong scientific notation. What is a wrong type scientific notation? This is one example. How is it wrong? Because this number here is too large. Remember that the coefficient or the digits is supposed to be just 1 point something all the way to 9 point something only, not 218. So yeah, the decimal here is in the wrong spot. It's supposed to be here. So to correct this, I write just the digits here in scientific notation. This decimal here, I'm going to move it 2 places to put it in the correct spot. And because I moved it by 2 places, I'm going to put a 2 there. This here is just a 218. I still have all of this times 10 to the 12 left, so I have to put it down here. And now I need to combine these. And to combine them, I need the rule of exponentials, which says that 10 to the a times 10 to the b is equal to 10 to the power a plus b. When I multiply 2 exponentials of the same base together, I just add the exponents. That makes this 10 to the 14th, and the whole thing is 2.18 times 10 to the 14th. Let's do another example. 0.3 times 10 to negative 4. What's wrong with that? Again, the digits here is supposed to start at 1 point something and up. It cannot be 0 point something. I do the same thing. I convert just the digits, just the coefficient into the correct format. Just this one, I'm going to move it in one place here. It's 3 times, and because it's some kind of decimal, so it needs negative power. It's 3 times 10 to negative 1. And don't forget that I already have the 10 to negative 4 over there. And then these two together, again, applying this rule here, I add the exponents. Negative 1 plus negative 4 makes negative 5, so it's 3 times 10 to negative 5. Now, the reason why I bring that up, because it helps us manually multiply numbers in scientific notation. On the other hand, if your teacher and professor allows you to use calculators, use calculators. I have a video just for that purpose, using scientific calculators to add, subtract, multiply, and divide. So use that. Assuming, however, that your teacher or professor doesn't allow a calculator, I'm going to show you how you multiply and divide scientific notation. If I have the number 1.8 times 10 to the 4th, and I multiply that by the number 7.2 times 10 to negative 9, then what do? Well, it's a multiplication all across. I just take these two multiplied by each other first. 1.8 times 7.2 is equal to 12.96. I'm not done yet. I still have these two numbers. So 10 to the 4th times 10 to negative 9th. And I use the rule that I already know. 10 to the A times 10 to the B is 10 to the A plus B. Just add these two exponents together. That gets me 10 to the negative 5th. And over here I have 12.96. So I'm done with all the multiplication. I need now to fix this to be in the right form, because 12 point something is no good. I need 1 point something. 1.296 times 10 to the 1st. And then the 10 to negative 5th is still there. I combine those. Final answer. That's how you multiply scientific notation, and you make use of this rule. Now let's talk about dividing. All right, let's take this example. 6.4 times 10 to the 6th divided by 8.9 times 10 to negative 2. Well, if you remember the rules of multiplying, dividing numbers, you know you can separate this out from that one. 6.4 divided by 8.9, I divide it out, and I get 0.719. And then over here, I have 10 to the 6th divided by 10 to negative 2. What do I do with that? Well, then I have to go back into my knowledge of algebra and recall that when I divide two powers of the same base like this, then all I do is subtract the exponent. So this means over here, I'm going to take 6 minus a negative 2. I'm going to subtract the top exponent minus the bottom exponent. 6 minus negative 2 is positive 8. I think I'm done, but I'm not. This number is in the wrong format. It cannot be 0 point something. I need to move this decimal point here over there. That gets me 7.19 times 10 to the. I moved the decimal point by one place, but what I started with was a decimal number. So that power has to be negative, negative 1. I combine these two. Now I have 7.19 times 10 to the 7th. Because now I'm adding the negative 1 plus 8 equals positive 7. All right, I'm going to now briefly tell you about engineering notation. We're not going to go over a lot of it. I'm going to give you an example. Let's take the number 40 million. If I write it in regular scientific notation, I write 4 times 10 to the 7th. I show people this number. They look at the 7 power of 10. They know that 7 represents 7 zeros, and 7 zeros is in the range of tens of millions. And they look at the number 4, so say, oh, it's 4 of the tens of millions. That makes it 40 million. Engineering notation takes it one step simpler and say that in real life, when we see this number 40 million, we call it 40 million. And million is 10 to the 6th, 6 zeros. So in engineering notation, they write 40 times 10 to the 6th. The reason for this difference here is a difference emphasis. The emphasis of scientific notation is to make sure that you know that the number that we started with is in the range of 7 zeros. It's in that order of magnitude. In engineering notation, they want this exponent here to be only multiples of 3. So 3, 6, 9, 12, etc. Because to them, it's easier to recognize that when you have 3 zeros, it corresponds to 1,000. When you have 6 zeros, it corresponds to 1,000,000. 9 zeros corresponds to 1,000,000,000 or 1,000 million. 12 zeros, in the US, we call it a trillion or 1,000,000 million. And then this number in front, we just add on to it. So it's 40 times 10 to the 6th is 40 million. So that's a different emphasis in the engineering notation. All right, so let's summarize. These are the rules of powers of 10. Positive power of 10, negative powers of 10, and how you multiply and divide powers of 10. This is how to convert from the usual notation into scientific notation. I don't want to call the usual notation standard notation because in the UK, standard notation means scientific notation. And this is how you convert back from scientific notation to the usual decimal or long number. And this is how you multiply numbers in scientific notation. And this is how you divide numbers in scientific notation. All right, I hope that helps. If you have any questions or comments, write it in the comments section below. I will put the link to the other video in the description section. Like, share, and subscribe for more contents. And thanks for watching. Bye.